Okay, in this video, we're going to talk about sill and floor construction. And as I've said in many other times, different areas of the country build buildings differently. Okay, so what happens here in the southeast, they may not do it the same way out west or up north. Okay, it's just regional differences. Sometimes it's building code, sometimes it's just personal preferences. So you're going to see, a variety of different things in textbooks and on YouTube and the internet and stuff like that. Um, but in floor framing, there's two different types of systems that are used. One is called platform framing, and the other is balloon framing. And platform is the most prevalent. It's the most common. And here's an example of a platform frame floor. Okay, in which you got your foundation wall. You have a sill plate or a mud sill, as sometimes it's called. It's usually a 2x6. It's pressure treated, and it's attached to the foundation wall mechanically somehow. And then a header or an end header, okay, and then a joist. The floor joist rest on the mud sill, and then it gets covered with plywood subfloor, and the wall goes on top of that, going on up. And the second floor repeats that. Uh, it, it it's the most common way because construction is easy. It's construction is quicker, and it makes just in the nature of the way it's built, it provides a fire stop between floors, meaning that fire can't come up through the floor into the next wall. Okay, and so here's a section view of the entire floor and wall system, so you can kind of see how it goes. How the wall is built on top of the floor, and it's actually built laid down and then stand up. Most of the time, they tilt it up and get all the walls in and braced, and then they build the second floor on top of that and go on up. Well, with balloon framing, you still have a sill plate or a mud sill, and then the studs rest on the sill plate and go all the way to the top plate where the roof is going to rest. Floor studs, there's a couple of different ways of doing that, but you have to provide fire stopping so that any fire with under the floor or within the floor system cannot get into the wall and go up in the wall like a chimney. Uh, a couple of advantages to this type of construction is that you have limited shrinkage because the building is not resting on the side grain of a piece of lumber. Okay, because when lumber shrinks, it shrinks more in this direction than it does in this direction. Um, a disadvantage to it, there's more work involved in adding the fire stops, and it's more difficult to construct because you do not have a platform to stand on as you're building this thing. Here's another example where the sill plate would be larger, and you actually put a header in and a joist, so it's almost like platform framing, but it is a little differently, at least on the first floor here. Okay, once you get up to the second floor, now you have to install what's called a ribbon, which is actually notched into the studs, and in the ceiling joist to go into the stud cavity and rest on that. It's a little more difficult to construct. Okay, joist and beams. The joist is the support for the floor, and they're usually almost all building materials, as far as framing goes, is made out of softwoods. Here in the South, we typically use southern yellow pine for floor and roof framing, and then we use what's known as SPF or spruce pine fir for wall studs. Okay, there's other varieties available, but that's kind of the common. Now, this is a chart from the book that I've told you before that you need to memorize as far as the sizing of our framing materials. What you need to know is the dry size over here. So a 2x6 measures 1.5 by 5.5. Okay, so in doing CAD designs, the dry size is the size we use as we're drawing these things. Okay, how do you know what size floor joist to use? Well, building codes provide floor joist and roof joist and rafter span data tables. And this is just an example of, there's a couple of examples here in the slideshow. There's several in your textbook, but they're based on the type of wood used, okay? The grade of the wood, and the lumber is graded based on, the grain, the tightness of the grain, the number of knots, the tightness of the knots, and things like that. So it's graded as to how strong it is, okay? And then the charts are based on the amount of live load uh, and and dead load. Okay, dead load is pretty consistent. That's the building itself. But the live load, um, you might have a higher live load in say a kitchen area than you might have in a bedroom area. A bathroom would have a higher live load than a hallway because the room has the capability to weigh more than another room. Okay, and then they're also based on deflection. Um, and deflection of 360 is pretty common. That's 360th of the span would be the deflection in the center of the joist once it's fully loaded. Okay, so here's an example, and you'll have the different sizes of joist, and then the spacing. 12, 16, and 24 are the common spacing for floor joist. And then each one tells you based on the type of lumber, how far it can span at that spacing. Okay. So as an example, we'll look at this chart here. We're going to do with southern yellow pine. Okay. And just for our example here, we're going to use number 1 dense. Okay, which is going to be this one right here. And we're going to use a 30-pound live load chart. Okay. And so we're going to go with number 1. And our span is 14 feet, which is the distance from the inside of one wall to the inside of the next wall. So what will work for 14 feet? Well, we could use a 2x8 at 12 inches. We could use a 2x8 at 16 inches because it'll span 14 feet 5 inches. We cannot use a 2x8 at 24 inches. It won't span far enough. We could use a 2x10 at 24 inches on center. We could do that, or we could use 2x12. So what we have to do is now we have to kind of decide on what's our most economical choice based on the cost of the lumber and the cost to install it, because a 2x10 costs more than a 2x8. Okay, because there's more wood involved in it. But if I were to use a 2x10 at 24 inches on center, I don't have to use as many of them as if I were to use a 2x8 at 16 on center. So these are larger, they cost more, but I have fewer of them. So you kind of make a trade-off of what's going to be consistent with the rest of the building and things like that. 16 inches on center is the most common for floor framing. That is the most common, and then anytime you deviate from the standard or the norm, you have a tendency to mess up your labor involved with it. Okay, so there's also steel framing that we can use. You'll see this a lot in commercial construction, but you sometimes see it in residential, in which the floor joist and the framing is metal C channels. They're kind of a C shape, and then metal wall studs and metal tracks. So everything is metal. It makes it fireproof. It's a consistent size, but you can't cut it and nail it like you would, traditional wood. But it is out there, and it is common in commercial. So our floor joist, on one end, they're supported at the wall. Well, if the building is too deep for our joist size, then we have to put a beam down the center. And the beams can be built of solid timber. They can be built up of multiple layers of framing lumber. They can be metal, or they could be engineered wood. Okay, there's quite a number of different, and these are just examples of how you could connect your floor joist to the beams. Okay,